Good morning, everyone. I'm Professor Kamini Subhash Patil, Assistant Professor in Department of Computer Science and Engineering, Science, at R.C. Patel Institute of Technology, Sherpur. Welcome to today's lecture on Language and Reasoning Models. Final year, BTech Final Year 26-27. The department visions to provide cutting-edge computer engineering education in data science while sustaining socio-moral values. The mission of department is to deliver state-of-the-art ICT-enabled teaching and learning to achieve excellence in data science education. To develop professionally competent data science engineers meeting evolving industrial and societal needs. To prepare employable professional with ethical value and a commitment to professional and social responsibilities. In today's lecture, we will discuss the topic is transformer, architecture of transformer, and many more. In this course, introduce to student modern language models and reasoning techniques in use in artificial intelligence. The objective is to understand how machine process human language and how recent transformer-based architecture have revolutionized natural language processing. The major course outcome are the course outcome one is apply the principle of transformer, BERT and GPT to develop solution for natural language processing task. Course outcome second, apply pre-training and fine-tuning techniques to optimize language model for real-world applications. Course outcome 3, analyze various evaluation metrics to assess the performance and reliability of language model. These outcomes focus on applying, analyzing, and evaluating modern AI tools. Now, let us understand what a transformer is. A transformer is a deep learning architecture introduced by Google researchers in the famous paper Attention is All Units in 2017. Today, almost every modern language model is built on a transformer architecture. Unlike traditional neural networks, transform process all words in the sentence simultaneously. Instead of reading them one by one, this makes them faster, more accurate, and highly efficient. Before transformers, natural language processing mainly used recurrent neural networks or RNNs and long short-term memory networks known as LSTM. In previous lecture, we will discuss all these things. These models process text sequentially. For example, in the sentence, artificial intelligence is changing the word and RNN read one word after another. Because of the sequential processing, training becomes slow. Another major limitation is the vanishing gradient problem, where the network gradually forgets information from earlier words in long sentences. Transformers solve this limitation using mechanism called self-attention, allowing every word to interact with every other word simultaneously. This significantly improve both speed as well as accuracy. Now, we will discuss about transformer architecture. Now, let's understand the overall architecture of transformer. The transformer consists of two main components. First one is encoder and second one is decoder. The first is encoder, which understand the input sentences. And second one is the decoder, which generate the output sentence. Between them lie the most important innovation called the self-attention mechanism. Together, these components allow transformers to understand language much more effectively than earlier models. Now, next is self-attention mechanism. Self-attention is the heart of transform architecture. This is the most important topic. It allows each word in the sentence to identify which other words are important. Each input word is converted into three vectors. These are, first one is query, second is key, third one is value. The model compares this vector to calculate attention score. These scores determine how much importance each word should give to every other word. Consider the sentence. The cat didn't chase the mouse because it was not hungry. Here, the word it referred to cat. Self-attention correctly identify this relationship, allowing the model to understand the sentence meaning accurately. This is one of the biggest advantages of transformer. Next, positional encoding and mask multi-head attention. Since transformer process all words together, they naturally do not know the order of words. To solve this problem, positional encoding is added. Positional encoding provides information about the position of every word in the sentence. The decoder also uses mask multi-head attention. Masking prevents the decoder from seeing feature word while generating text. This ensures the text is generated one word at a time without cheating. This mechanism is essential for applications such as GPT and language generation. Now, next is add and norm and multi-head attention. The next important component are add and norms and multi-head attention. The add and norms layer perform two tasks. First, it combines information using residual connections. And second one is, it is normalize the value of stabilized trend. After this comes multi-head attention. Instead of using only one attention mechanism, the transformer uses several attention heads running in parallel. Each head focus on different relationship between words. Some heads learn grammatical relationship, while others learn semantic meaning. This enables the model to understand language much more effective. Next is fed forward. After attention, every word passes through the fed forward network. This network consists of two linear layers separated by relay activation function. The feed forward layer defines the information for every word independently. It improves the representation before passing it to the next layer. This step is very important for improving the prediction of accuracy. Here is the mathematical function of. Now, next is linear layer. The decoder produces an output vector for every word. The linear layer converts this vector into vocabulary space. For example, if the hidden vector size is 550, 512 and the vocabulary contains 15,000 words, the linear layer converts the 512 dimensional vector into 15,000 possible words score. This score are the passed through the softmax function. Softmax converts the scores into probability. The word with the highest probability becomes the predicted output. This process continues until the complete sentence is generated. This is the course outcome of about topic, and this is the reference for about topic. Thank you for attending today's lecture. In this lecture, we learn about the need for transformer models, the limitation of RNN and LSTM, and the major building block of transformer architecture, including self-attention, positional encoding, multi-head attention, feed-forward network, and the linear net. Thank you. Have a wonderful day.